get started. This is Adam Shostack. He's here from Microsoft, where he works in the Trustworthy Computing group. And he does most of your threat modeling stuff, and he's written a book about it, which is on sale now. So anyway, he's going to talk about threat modeling and Star Wars.
Yes. All right. Thank you for the simplest and cleanest introduction I've ever had. This is excellent. So, over the years, we've managed to create an awful lot of complexity around threat modeling. But I believe that everyone threat models. It's a natural thing for people to do to throw their presentation remote around. To think about their threats, to abstract them in some way, to try and derive lessons from them. And so today I want to talk about four things and give you real possible takeaways. The first is a simple approach to threat modeling, and this is really the industrial perspective that we have at Microsoft as we train tens of thousands of people to threat model software. The second thing for you to take away is top 10 lessons that we learned that I learned really as I was working on this book. The third thing is some research questions that I think might be interesting to the folks in this room. I hope are interesting to the folks in this room. And then there's some bits on learning more and some resources. So to start off with, a simple approach to threat modeling. Why do we need a simple approach? Because threat modeling is one of those things that if you go and you search and you say, how do I threat model? You'll see a lot of different perspectives. You'll see perspectives that say you should start by listing your assets. You'll see perspectives that say you should focus in on your attackers. You'll see perspectives that you should focus in on your software. And sometimes you'll see perspectives that you should do all three of these things all at once. And so in the course of working with people and training them to threat model and getting their feedback on what we were training them on, I've come to a very simple approach with four questions. And the four questions are, what are you building? What can go wrong? What are you going to do about it? And did you do a good job at 1 through 3? So why would I start with what are you building? Things like assets, things like attackers seem like natural places to start. If you don't have an attacker or a model of your attacker, then what are you defending against? And the reason that I think industrial software development threat modeling should start from what are you building is because that is the thing which the participants actually understand better than anything else. We might hope they understand attackers, we might hope that they understand what assets they're defending, but if they don't understand the software or the system that they're building, they are unlikely to succeed at delivering it. And as such, it makes a useful entry point, a useful way to get going compared to some of these other things. The question of what can go wrong, many different ways. I'm going to talk first about Stride and then about some others. But there's lots of ways to think about what can go wrong. And actually, let me do that before talking about what we're going to do about it or doing an acceptable job at those things. So, as I said, I'm fond of Stride. Stride stands for spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. And this is a mnemonic. It's a way to help people think about what is likely to go wrong. And actually, let me pause at this point and ask, how many people in the room are in the security side of this world? A few. Networking? Other areas? People who haven't, well, tell me what they are. Don't just... Privacy, software development? Okay. So if you're in security, Stride can be very helpful as a mnemonic, as a way of remembering these things. And if you're not familiar with Stride, let me walk you through it. So the S in Stride stands for spoofing. And And spoofing is pretending to be something or someone you're not, whether that's pretending to be a Nigerian prince with millions of dollars, pretending to be PayPal.com, or pretending to be a stormtrooper and walking through the Death Star. Each of these involves pretending to be something you're not. Tampering is all about modifying things you're not authorized to modify. So that might be changing packets on a network, it might be modifying bits on disk, it might be turning off the controllers to a tractor beam. Repudiation is all about saying you're not responsible for something or telling a story to try and avoid responsibility. So it might be saying, I didn't order those magazines, or I didn't click on that link, or we've had a reactor meltdown, very dangerous. So information disclosure is about getting access to information you shouldn't have. It might be eavesdropping on a network, it might be reading files off of disk, it might be pulling information together from various sources and combining them. And I don't have a Lego thing here because I actually believe that information disclosure is such an important issue in Star Wars. How many people believe that Star Wars is about the hero's journey, or Luke's growth into a man, or even his relationship to his father? Anyone? Anyone? Okay, we've got a couple of hands, and Serge, I regret to tell you that you're wrong. Star Wars is the story of information disclosure. From the very opening scene where we see Princess Leia's ship being pursued by a Star Destroyer, all the way to the epic battle and the destruction of the Death Star, Star Wars is all about information disclosure. I don't know why so many people get this so wrong. It's obvious once you look at it. So the D in STRIDE stands for denial of service, and whether that's filling up a disk so that you can't write to it, filling up a network so that you can't get packets back and forth, or freezing Han Solo in carbonite, it's about preventing access to resources. Lastly, the E in STRIDE stands for elevation of privilege, and elevation of privilege might involve running commands through SQL injection that you're not authorized to run. It might involve putting code into a website via cross-site scripting, or it might involve telling some stormtroopers that these aren't the droids you're looking for. Each of these is exceeding the authorization granted to someone. So, why do I have this silly little Star Wars thing? I have this silly little Star Wars thing because it's a mnemonic. It's a way to help you remember the information that you just saw. Because one of the contexts in which I work is that we ship a lot of software, we have a lot of people working on that software, and those people have a lot of requirements placed on them. We ask them to think about security, we ask them to think about privacy, we ask them to think about reliability, we ask them to think about accessibility, internationalization, programmability, maintainability. There's a list of about 20 of these things in our standard spec templates, and a developer has to think about all of them. And then they have to have time to write their features. And so we're constantly looking for ways to help people get a foothold, to do the basics well, and to realize the limits of what they're doing. And so using STRIDE as a mnemonic, providing this sort of content, is helpful to those very busy people. So what are you going to do about these things? You know what you're building, you represent that, for example, with a whiteboard diagram or a data flow diagram, and then you think about what's going to go wrong, and then you need to fix it. And the general approach to fixing it is, well, there's a very broad set of things here. One of the things that is important and valuable in the shipping software process is to exit the threat modeling process in a way that connects to the rest of software development. If you sit down, you think about security, and you write some stuff down on a piece of paper or in a document, you need to make sure that that document gets picked up by someone else. It's delivered somewhere. And so rather than threat modeling reports, I like to think about threat modeling being a thing which generates bugs. Because if you're shipping software, you have some way of tracking bugs, you have some way of managing bugs, and that way of tracking and managing bugs is a natural place to actually put information about threats. I'm going to skip over for now the acceptable job question because I think that that's more of an industrial practice question that might not be so interesting. I'm happy to talk about it later on if you have questions. What I'd like to talk about next is the top 10 lessons, things I've learned from talking to an awful lot of people in an awful lot of places about threat modeling. And I'd like to present each of these in the form of a trap, something that can pull you in and make it difficult to effectively deliver your threat modeling results as part of a software development or as a technology development process. So the first trap is a phrase that people in security are fond of saying, which is, "You're never done threat modeling." And in a lot of ways, this is a true statement. You can keep going, you can keep analyzing, you can keep finding new sorts of issues. But if I go to a VP of development and say, "I would like you to insert this thing into your project plan," and they'll say, "Great, I'll insert this thing into my project plan." I'm being very optimistic, by the way. And they'll say, "How long will it take?" And you say, "It's never done. You're never done threat modeling." And they'll say, "Thank you very much. I'll get back to you on that one." So rather than thinking of never being done threat modeling, and I'll point out that this is model, what are you building, identify threats, what can go wrong, mitigate, what are you going to do about it, and validate, check your work. I like to think of this as a loop that we can unroll, and we can consider it as a set of stages which finishes. Same tasks, but avoiding the trap of saying that you're never done. There's also a trap of thinking of threat modeling as a monolithic thing, that you must follow precisely these steps, and every threat modeling approach will involve these steps. I now think of threat modeling much more like Legos. It's things which you can snap together in a variety of ways, and those building blocks create an approach to threat modeling. So for example, you could use data flow diagrams, DFDs, and a data flow diagram has a couple of advantages in threat modeling. First, it's super simple. There's only four types of elements in a data flow diagram. There's processes, there's data flows, there's data stores, and there's external entities. And so I can teach it to you in 2 minutes. You can understand it. It looks remarkably like a whiteboard diagram. Second thing that's advantageous about it is that threats tend to follow the data. And so if you're using a data flow diagram, the threats will tend to move along the data flows rather than the control flows. But you don't have to stick to data flow diagrams. You can also use swim lanes, you can use UML, you can use any type of diagram that helps you abstract away some of the details of the software and help you think about what's going to go wrong. The only thing you have to add is some sort of trust boundary, something between the different principles in the system so that you know who's interacting with whom. Similarly, you can identify threats in a great many ways. You can use STRIDE, which I talked about. You can use KPEC, which is the MITRE Common Attack it's an attack library from MITRE, the Common Attack Pattern Enumeration and Classification. You can use attack trees. I'll talk more about these in a few minutes. There's also a variety of ways you can think about integrating privacy into threat modeling. So you can think about using something like contextual integrity or let me just explain briefly. So contextual integrity is the idea that many privacy violations are a result of information flowing outside the social context in which it's provided. So a doctor's office might be a context, and I might say, "Hey doc, I have a rash." and my doctor might go talk to a specialist about it. And all of those are expected data flows in a medical context. But if I encounter my doctor having that same conversation in the context of my supermarket, I'm going to be upset, because that's outside of the context in which the information is expected to flow and how it's expected to flow. There's a professor at George Washington named Dan Solove, who has a taxonomy of privacy harms, and each of these can be plugged together. And when you start thinking about these as building blocks that can be plugged together, it helps you avoid the third trap, which is that people say the way to threat model is this or that. So for years, people, including myself, have been saying use Stride, use data flow diagrams, and I believe that's good advice. But if I came to you and said, I'm working on this new programming project, what language should I use? You'd ask me some questions. You'd say, well, is it a web front end? Is it a cryptocurrency, in which case you should totally use PHP? Or is it a device driver, in which case you should obviously use C, or not. But the different
There's always Perl.
The different tasks require different languages. Different languages have different strengths and weaknesses. And so, speaking of Perl, there's more than one way to do it. We should think about threat modeling and move away from the way to threat model is to the way to threat model this is. So, relating to this, I like to think about this as a continuum. And over here, we have people who are really focused on security. Then you have people who have other specialities, whether that's networking, whether that's databases, whether that's privacy. And Stride, I've come to appreciate Stride over the years. I used to rail against Stride because people refer to it as the Stride taxonomy. It is a poor taxonomy. It does not help you categorize things in a useful way. There's easily found examples. Of places where it is simply hard to say whether or not something is tampering or elevation of privilege. So if I modify a URL and it says admin equals 0 and I change it to admin equals 1, is that a tampering attack or an elevation of privilege attack? My answer, and this is what allows me to really like using Stride, is it doesn't matter. You found the attack. That's what Stride was intended for. And so it's useful, but it's only useful if you have this mental repertoire of ways in which people spoof, of ways in which these attacks take place. So KPAC, the attack library from MITRE, has about 500 different attack patterns in it. And each pattern includes the attack, it includes what technologies it tends to show up in, it includes how to test for it, it includes how to address it. It's much more structured, it's much richer information. But as a security expert, I find it slower and less productive to go through than using a system like Stride. Somewhere in the middle are things like attack trees. Attack trees are a way to organize either organize your thinking about what might go wrong in a system, or to take advantage of someone else's tree that they've already built and use that to find things that will go wrong in your system. Now, I'm often asked about checklists. People here hate checklists. I used to hate checklists. It's okay. Many people hate checklists because they're too prescriptive, they're narrow. People scorn checklist-based security. And I read Atul Gawan's checklist manifesto, and I've come to love checklists.
Just a comment, if you ever have your house and are doing major renovations, you will so love the punch list.
Absolutely, and the reason you love it is because there's a predictable set of things that go wrong. There's a set of yes or no questions that you can ask, and I don't know about a house punch list, but most checklists for operating an aircraft are between 5 and 10 items. They're a reasonable length for the task, rather than being overwhelming and tedious. But the thing that those properties don't do is give you a model of what might go wrong that you can analogize from, that you can learn from. You can say, huh, this sort of thing went wrong over here. Maybe something similar will go wrong over here. And so, much as I like checklists, I think they're a little disjoint from threat modeling. Yeah?
I think a better way to think of checklists is checklists are not a way of showing what goes wrong, but of making sure things go right.
Yes. Yes, you have a set of things that you know you need to make right, but it won't help you develop an understanding of what goes wrong, precisely.
Well, I mean, I think normally, the role of the checklist is to prevent you from overlooking things that aren't your primary focus. So, for instance, the book that you talked about, I read the abbreviated version of that. There was a long article somewhere about this, and how, I think it might have been New Yorker a couple of years ago,
Okay.
and how rolling out checklists in the hospital reduced mortality rates by some absurdly large number, and it was just because they would forget to do basic
Number
things.
one, wash your hands.
Yeah,
Yes,
wash your hands.
literally, washing hands and draping patients
Yeah.
often get missed. What doesn't get missed is making sure that the oxygen flow is off, because if the oxygen is flowing and you don't have a hose there, you get combustion, and that's highly available, and people don't forget to turn off the oxygen tanks.
Yeah, but it's the everyday minutia that gets overlooked because it's tangential to the primary task.
Yep, precisely. I actually use...
That said, there are also a ridiculous number of hospital, incidents where they amputate the wrong leg, which checklists have also addressed.
That's also why they write on the leg.
Yeah,
Yes.
it happens more often than.
Yeah. So yes, for the right purposes, checklists are great. So the right way to threat model is the way that helps you find good threats. And I've said bad things about both asset-centric and attacker-centric approaches. And so let me talk about that just a little bit more. I've mentioned that the asset-centric, I don't like it because it's not the thing that developers start focusing on. Attacker-centric, I love spy novels. I really enjoy them as a way to relax. But I have no idea what a real-life Russian spy would actually do if they wanted to compromise a system that I'm responsible for. I have ideas, I have perspectives, but I don't know how good they are. Worse, if I start by focusing in on attackers, I'm introducing two distinct places where errors can creep in. The first is I might not list Chinese spies, I might only list Russian spies, or I might not think about hacktivists. I might have the wrong set of attackers. Secondly, I might believe they behave differently than they actually do. And so, starting there, and let me come to you in just a second, starting there is a place that it's easy to introduce errors, and again, it moves away from the thing that you hope the people working on the system are most likely to understand. There is a place where they do make a lot of sense. Both assets and attackers are great ways to think about prioritizing what you're going to fix. Because once you've said, oh, there's a tampering attack against this thing, is that important? Thinking about what asset is in that data store or what data moves across that data flow lets you prioritize in ways that you can't if it's just some completely abstracted data flow. Secondly, understanding something about attackers can be very helpful in responding to the objection, well, no one would ever do that. And it's an objection that you run into all the time, and knowing what attackers do can be very helpful there.
I think there's one other limitation on attacker modeling, which is unfortunate because I actually like it, is you are limited by your evil twin. You cannot model an adversary who is more creative, more resourceful, and more innovative than your evil twin, because if you could, you run that model and become more innovative, resourceful, creative than you are.
Actually, last Thursday, high-ups from the CIA testified before Congress that Russia would never invade Ukraine. No, seriously, that was
No,
a day before they did.
Well, the CIA, is this being, well, I'll just say it, what the heck. The CIA has a long, proud history of excellence, true excellence in their predictive capabilities. But as I think Niels Bohr said, prediction is hard, especially about the future. So focusing in on the way that finds good threats is important. And when I'm giving this talk in an industrial setting, I have my follow-on, which is that we have a trap of focusing on finding threats. Finding threats is a lovely thing, and especially here at ICSI or in a research environment, finding threats may be all you need to do. I'm very fond of papers that present both an attack and a way to resolve it, but
you get more publications if you separate the two.
you get more publications if you separate the two. You may get more publications by separating the two, but oftentimes I find the fixes proposed in the papers, there's a reason that fix doesn't actually work in the real setting. I have a colleague who did his PhD and pointed out a usability flaw in Windows. And then he joined Microsoft and he spent some time trying to fix it. And it turns out that fixing it would have required literally billions of people to go review their ACLs and see if they still mean the same thing after he made a change. And so, great work, I really like the work. Fixing it turns out to be expensive in a way that he hadn't anticipated. And so, in an industrial setting, I'm really focused on find threats in order to fix them. In a research setting, I think finding threats is a lovely thing and I enjoy doing it.
Now he's left Microsoft and is at Google, where it's much easier to.
I'm not naming.
Where Google can check your ACLs for you.
I'm not naming names. I'm just telling a little story, illustrative and all that. The fourth trap I think about is believing that threat modeling is solely for specialists. There's often a time where someone will say, hey, I'll be the threat modeling expert and you can come to me and I will work with you on this. I look forward to a day when everyone who does software development knows a little bit about threat modeling. I don't need them to be an expert, but knows a bunch, knows something. If you had a software developer come in to a company and say, I've been a professional software developer for 5 years and I know nothing about version control or branch management, that would be a big red flag. You probably wouldn't hire them. So I aspire to a time when everyone who works in software, everyone who works in building systems, will know a little bit of threat modeling. Yes?
I guess I'm probably the most outsider here. I think this slide kind of speaks for me. I'm an app developer.
Cool.
I build systems that I hope will be secure, but I've heard about version control, of course, but I've never heard of threat modeling before. And so I wonder how much of this is, the fact that it's just not known by the general people, or is it just the nomenclature is strange?
It's a great question. So how much of why is it that people don't understand threat modeling? And I think there's a couple of reasons. The first is because we've often presented it as a black art, something that you're born with, something that is innate rather than something that's taught. A lot of the approaches, if you do a web search for threat modeling, you'll find a lot of processes that are 10 steps, 15 steps long, that use a lot of jargon, that are hard to get started with, hard to execute, hard to know when you're done. And also you have ones that start with things like, think like an attacker, and look at your system and figure out what will go wrong. As an app developer who's never heard of threat modeling, is that a realistic thing for me to ask of you? Probably not. And so I mean, I'm here for a conversation, but the reason I wrote the book is because way too much of this is way too hard. The graphics on the book cover resemble the graphics on Elevation of Privilege, which is a card game I made. It's Creative Commons licensed. It's available as a free download. And the reason I made the game is exactly your situation. There's too much, it's too hard. You download the card game. I've heard from a lot of people who don't have a security background that it has helped them get started and made threat modeling accessible to them. So I think the fundamental problem is people like me did not make it easy for people like you to do this work. And so I'd like to make it easy for you. So trap number 4 is threat modeling in a vacuum. It's easy, and I'm using air quotes here, it's easy for a developer to add logging while they're writing the code that explains what the business logic is and what decisions are being made, why. It is nearly impossible to add those once the code is deployed. Now, you can say, okay, but if it's open source, I can add it. I think of that as a development activity, not an operations activity, right? The people writing the code should add the logic to log. It's easy for them to know where that makes sense, compared to, I just downloaded 1 million lines of code off of GitHub, and now I'd like to add some logging logic to it. I have to understand the logic. I have to figure out where to put the logs. That's a difficult thing for me to do as someone who's new to a package. So this isn't a matter of source availability or not. It's a matter of the people writing it understand it. In sort of the flip side of that, it is very hard for the people who are operating or who are developing the code to make sure that someone actually looks at the logs. That's just outside of their purview. And I'm pretending that there's this magical split between development and operations, and we all know that there's DevOps. But for the purpose of thinking about this in terms of different places along the chain where software is developed, delivered, and deployed, there's different organizations are able, or different groups are able to address threats differently. The people who made this laptop have an ability to address certain threats with regards to what ports do they put in, how well does it lock, etc., etc. The people who make the operating system have certain things that they can work on. The people who make the applications that run on top of it make certain assumptions about the OS, certain things that they defer to the user. And so if you threat model as if your thing exists in a vacuum, there are some threats which are really hard to address, And information about threats should flow both directions in the supply chain. You should tell people who are calling your code what you expect to have happen. You need to validate this information to use this API safely. You can take that to a bad extreme, say Stircat. The manual has said that Stircat is dangerous to use for decades, and eventually the function got replaced. So that happened because the people writing Stircat had a threat model, which is, well, the people using my function will know exactly how long their strings are and do the right thing. You laugh. I don't know why you laugh. It seems like a great assumption if I'm just trying to ship a library. And so you can use things like a security operations guide to communicate, to anticipate what you expect someone in operations to do. You can use it to check those assumptions. You can use non-requirements, and could I get a time check? Because the clock is actually glared, so I can't.
3:15.
It's like 3:15. Okay, I'm going to speed up a little bit. Trap number 5, going exactly to your point, is the idea that threat modeling is born, not taught. We need to develop some muscle. We need to develop muscles when you're learning to play an instrument. If you hand me a violin, I'll make ugly sounds with it, not music. There's also people who will take a violin and play it at Carnegie Hall, and that's great. You don't need to aspire to Carnegie Hall to enjoy playing an instrument. I have a lot of friends who just jam with their friends. Maybe they play in a band. They're never going to make it to Carnegie Hall. They don't have the dedication. They don't have the motivation. They might not have the time. And so we should look at threat modeling as a spectrum where people are developing skills to some point where they're comfortable, rather than either you have it or you don't. And so as Lando Calrissian said, we've got to give them more time. Similarly, thinking of threat modeling as a single skill rather than as a set of skills, I'm going to skim over this, but just say that there's technique and there's repertoire that you can think about. Trap number 7 is to say think like an attacker. Think like an attacker is a great exhortation after someone's been in grad school for a few years or after someone has been trained to beat on things. But if you're not trained to do this, it's a little like saying think like a professional chef. However much you might enjoy cooking, if I ask you to go purchase the food for a restaurant with 78 tables that's going to turn over once tonight, and minimize food wastage and maximize profit, you're going to have a hard time doing that.
Go with a prefix menu.
I don't know. That depends on your model of the restaurant. If you're going to be working at a Burger King, a prefix menu might not be the best choice.
Well, if they have that.
They have the Happy Meals.
The number 1, the number 2.
Indeed. Trap number 8 is forgetting that there's always at least 2 models. Sometimes people say, okay, what are you modeling in threat modeling? The answer is you're modeling at least the technology that you're building, the threats that might apply to it, and sometimes also the person. I'm going to skip over this bottom bit and say that trap number 9 is a laser-like focus on threats. There's an important interplay of threats and mitigations and requirements, and let me walk through each of these briefly. So, requirements drive threats. If I say that the plans for this battle station must remain confidential, then we know that there's information disclosure threats and we need to mitigate them. Now, it goes the other way. Maybe the Empire has some open source advocates who say we should publish the plans for this battle station, and then many eyes will help us find all of the problems. It could happen. There's open source advocates all over the place. You can go in either direction to find these threats, that threats help you understand your requirements and that requirements help you find threats. There's an interplay between threats and mitigations. If I'm threat modeling my house and I'm thinking about my front door, I put a lock on my front door, I'm done, right? No, obviously someone can pick the lock, someone can kick the door in, and so I can get a... Let me get to that.
You can forget to lock the lock.
You can forget to lock... So there's threats again, but you can forget to lock the lock. So I might have an automatically locking lock that when you pull the door shut, it bolts itself.
And then you lock yourself out and getting the cat.
Or you forget that someone can come in through the window, or that the back door lock has been jammed for years and you can't even lock it. So it's important to think about threats breadth first when you're building a system.
But at the same time, modeling attacker is useful in that case because I don't actually have to have my house be strong enough to mitigate the burglar. I just have to have it be stronger than my next door neighbor.
That is true for the houses. It's not as true when you move into technological systems.
Where you can parallelize your attacks.
Where you can parallelize your attacks, where you can automate your attacks, and where people will sell you automation to use the attack that you don't understand.
I think the more important difference there is the targeted versus untargeted attack.
Yeah.
I mean, if we're talking about, Microsoft is a target.
And also, behavior can affect things. So if you have, say, an NRA bumper sticker on your car, you're going to need higher security on your house.
Maybe.
I think that's
one of the few things that are more valuable stolen than anything else.
On the other hand, you are driving up risk to a burglar. who might worry about getting shot differentially versus a house that doesn't have. But
And then everyone who sees your car is also
Targeted again, right?
so risk management is difficult. Things that you can't mitigate, if you're not willing to invest in mitigating them or you're not able to mitigate them, you need to ask if it's really a requirement to defend against those threats. Because if it really is a requirement, then you will invest in the mitigation. So there's an interplay there. Line number 6, the dotted line. For a long time I sort of scratched my chin and said, well, is there really something there? And it occurred to me that a requirement to implement a mitigation or a control without any threat being present is actually a really good description of a lot of compliance activity. And so maybe this illustrates a little bit why we recoil from compliance activity. Trap number 10 is threat modeling at the wrong time. You don't want to be like this guy standing on the bridge of the Death Star saying, "Sir, we've analyzed their attack pattern and there is a danger." It led to very bad consequences for Grand Moff Tarkin and his aide. And who knows, maybe if they'd done a little bit better threat modeling while the Death Star was being constructed, they would have realized that building long trenches leading up to their thermal exhaust ports is an ineffective design, and that they should have built those trenches in some other way.
Or just make sure you don't have any remaining space warlocks going around.
Well, they tried that, it didn't work, and there again is the trouble with trying to model your attackers, is they believed all of the Jedi were dead, and they missed one. So I want to switch gears and talk about, since I am here at a research institution, talk about some places where I see potential for valuable research to take place. And my most essential claim is that we can and should study the ways in which we go and look for problems in real industrial systems. The book has a family of approaches that interrelate. It is not complete with reference to what exists today. It's reasonably complete with what has been shown to work for people beyond the inventors of systems. If someone else can learn to use it and has documented that, then it's more likely to be in there. But I make no claim that the approaches in the book are perfect in any way. I believe we can do a lot better if we start looking for frameworks to identify threats. I am sure we can discover and develop new and different ones that may be more useful for various audiences, for various types of systems. I've broken things down into 4 questions. I believe those 4 questions are simple and useful. Maybe there's a 5-question approach, maybe there's a 3-question approach, maybe there's some other frame that helps people find threats better, fix threats better, or otherwise is more useful than what I've put forth. I would love for someone to demonstrate that there's better ways to do these things. The question of approaches to better security is one that interests me a lot. It's been a professional interest for 15 or so years. How do we improve security? And I think that there's this there's set of organizational constraints which are really understudied, that people don't understand, that we haven't really cataloged or understood in useful ways. So one example of this is training. I used to be responsible for threat modeling training at Microsoft, and we've got about 30,000 people whose job is some type of software engineering job who we wanted to train on threat modeling. You deliver an hour of training to 30,000 people, that's 15 person years. That's a lot of time. That's time that we could spend. I mean, if you're an app developer, 15 person years, you can develop a pretty cool app with that time, right? How do we maximize, and I should say that we actually do require security training of every engineer. We invest that level of time. We would like to get more value out of that time. How do we effectively do that? There's time constraints. If I have a system that I'm building and I can get a month of Nick's time, he's going to do a really good job finding interesting threats against that system. But there aren't that many Nicks, and a month of his time is hard to get. And so how do we get the most value out of the time that people are putting into this sort of work?
There's also weird non-linearities. An hour would not be enough, but beyond a week it might be wasted.
You can usually find really interesting stuff in an hour, but yes, and there's another question. I bet that there is no relationship between number of lines of code and number of interesting flaws. So going back to the question of a VP of R&D, how do I take this thing that I'm building or thinking about building and make a prediction about a good amount of time to spend looking for problems? Right now, it's sort of catch and release, right? You go and you spend time until people are all sitting in the conference room scratching their head saying, I don't see anything else. It's incredibly inefficient. It's not very repeatable. It's not going to get you high quality answers, but it's in some ways the best we can do. So I think there's a slew of things which inhibit the industrial adoption of new approaches to threat modeling, and that we should understand those, and that it's a worthwhile research question to see how to overcome them. There's a bunch of ways in which I think we can analyze this. We can compare various formal approaches, and I think of what I'm doing with things like Stride as a structured approach. It's not free form, but it's not a mathematical formalism. And so as I think about what does it look like to actually compare between these approaches, how should I compare Stride to, say, using a formal language like Z to analyze my program and try and prove properties about it? Each of these has advantages, each of these has disadvantages. What's the right framework for thinking about those advantages and disadvantages? Once we have a way of thinking about that, we can think about how to improve these structured approaches that exist. Related to this, I think one of the biggest barriers to industrial adoption of formal methods is usability. There's a lot of these systems where I pick up a paper, and frankly, it's been a long time since I've been in school. My Greek was never very good, and there are symbols I don't know how to read and I don't know how to type. And when I get to, if I'm going to use this analysis technique, I have to re-implement it because the code isn't licensed for non-academic use. These things are barriers, and I would encourage you to think about the barriers. I'm not giving you all of the barriers. I'm saying listen to the people who you would like to have using these systems and listen for the reasons that they're not adopting them. Each of those reasons represents another paper. You overcome that concern, there's another paper in it saying increasing adoption of this. Another thing that I think is worth looking at is there's some really, really important work in terms of isolation, in terms of provable code, in terms of building blocks for making things more secure, or making things secure by design rather than making them secure by post hoc analysis. The challenge which we face is that, well, there's many challenges, but one important challenge is I don't necessarily know how to relate type safety so my code is not vulnerable to these categories of attack. I know that type safety will help me with buffer overflows. Will type safety help me with SQL injection or with spoofing? finding ways to connect the different streams of activity and research seems to me like a useful possible area of investigation. Another thing which I would encourage you to consider investigating is ways to teach these things. I believe that the threat modeling approaches that we've developed in industry have value. I believe that they may make some degree of sense as part of an academic curriculum. It's not, here I want you to learn how to use this version control tool. These are ways of thinking. These are ways of examining the world, understanding the world. I'm not an educator. I don't know how to teach these things to the best way possible. The last thing I want to do is mention this paper, and I'm not going to try to pronounce his name because I always mispronounce it and then I feel bad. But there's this fascinating paper which came out in Requirements Engineering 2 months ago now, titled A Descriptive Study of Microsoft's Threat Modeling Technique. Really interesting paper. I do want to mention just briefly that the approach is not actually Microsoft's threat modeling technique. What he discusses has never been used at Microsoft. But setting that aside, what he did was he took a bunch of take a bunch of grad students, gave them descriptions of software, told them convert this UML to a DFD, use Stride to find threats, use misuse cases to document them, and then they simply described how long did that take, what was the extent to which they found threats that met the assumptions, what was the amount of time consumed. And what I think is fascinating about this is they're taking a very applied, practical thing, and they're saying, okay, what can we measure about this? What are the simple measurements that we can take? What do we learn from those measurements? And what does that give us as possibilities for improvement? And I think that this sort of descriptive empirical study is something which it can be tremendously useful towards advancing the field. So with that, to close out, I'd like to encourage you, for those of you who teach, to teach something about threat modeling, to design new approaches to threat modeling and more broadly to design analysis, because these techniques are deeply valuable to those of us in industry who are trying to develop more secure systems, who are trying to ensure that version on version our software gets better. And lastly, help by developing tools for comparing between the different approaches. There's a lot of approaches out there in the world. It's difficult to say what the best approach is. It's difficult to characterize the audience for a lot of these approaches. And I think there's really an opportunity to do empirical software engineering science around the different ways in which we might tackle these problems. And to the extent that we do so, we will get more secure systems out the other end. And so, to close, I'd just like to quote George Box, a statistician, who said that all models are wrong and some models are useful. And I encourage you to look at the useful kind and see how they can help us. So with that, thank you very much for your time.
Should we do questions now, or do questions with Kate up there?
Does anyone have a question in here that we want on the recording? If so, I'm happy to take it in here. If not, yes?
I guess just another kind of high-level question. How much of the goal of threat modeling is to convince yourself versus convincing other people?
Ooh, good question. I like it. How much of the goal is to convince yourself versus convincing others? Wow, that is actually not a frame that I had placed this in before. Let me reframe that just a little bit to a way that I think I have a clearer answer, which is how much of it is to convince yourself versus how much of it is to communicate with others. And And there, I think the answer is most of it is about communicating up and down the supply chain. So for example, you mentioned being an app developer. So whatever platform you're developing apps for has a certain set of security functionality that they provide to you and a certain set of things that they expect you to do. Right? So just as a simple example, there's probably a library call that says do this over HTTP and a different library call that says do this over HTTPS. And you need to know that the HTTPS one is available, when you should use it. And so threat modeling is what do you need to use from their platform to give your customers more effective security? And then what do your customers need to do? So for example, let's say you're making a secure messaging app of some type. What do your customers need to understand in order to securely use your app? Right? What's the trade-off of saving a passcode, for example? And so I would say that the goal of threat modeling should be to communicate in both direction, that you have a good degree of confidence that your design addresses the threats that people should be concerned about to the extent that you're able to do so. So that?
Yeah, I guess when I think you can communicate two directions. Sort of one is to end users who are non-experts,
Mm-hmm.
then also to perhaps experts who can certify or give you some sort of like site seal or something that
Mm-hmm.
is also useful.
Yes. Yeah, you can communicate to end users and you can communicate on to experts, and both are important, but it's easy to convince yourself of something. The goal of threat modeling should be to make your thoughts concrete enough that other people can understand what you thought about for security and make decisions about does your app meet their security goals or not. All right. Well, thank you all very much for coming. I appreciate your time.